Okay, so this is part 284C3M1b7c8e13c9c6d3p38d19d7b23. It's line 22f1fa19c3m1b7c8e13c9c6d3p38d19d7b23 X-ray Photoemission Ois Spectra Part 8 5G Wow Seti. So there's several videos before this one. There's the alien radio signal. Get it out of there. So in this video we're going to talk about Fourier transforms, photoemission events, keyword research, wow data. Okay, so there's the line of data. Previous video was part 7 for the X-ray Photoemission Ois Spectra. March 15th 2013 is when I was working on it. Today's May the 12th. Okay, so this is all based on some PDF files that I found after doing a Google search for the keyword. And I added water and vapor to it, and we'll be doing a cross-reference with those words along with long-distance communications when we get to line 27. So X-ray photoemission spectra came from Googling Ti-sapphire laser and thin film beam splitters, then passive optical network, then radio frequency over glass. I added the word steam and vapor to see if the two would go together because I use obsidian glass in the core of the UFO spaceship, so I want to know if this radio frequency glass, what we could do with it. So then we have water vapor plasma treatment of glass surfaces. Then we have X-ray photoemission Ois spectra, which all ties in with the communication signal as well as powering this UFO spaceship thing that we can build. So the quote from Wiki: from the theory of Fourier transforms, T and the little t are linked by the indeterminacy relation. So it's TT greater than minus H with a little line across the top of the stem. You must guys get a kick out of the way I describe these letters. I don't know how else to describe them. I've never seen them before. So the photoemission event leaves the atom in a highly excited core ionized state from which it can decay radiatively, fluorescence, or non-radiatively, typically by Auger decay. Besides Lorentzian broadening, photoemission spectra are also affected by Gaussian broadening, which we talked about Gaussian before, whose contribution can be expressed by this equation. Three main factors enter the Gaussian broadening of the spectra: the experiment energy resolution, vibrational, and inhomogeneous broadening. The first effect is caused by the non-perfect monochromaticity of the photon beam, which results in a finite bandwidth, and by the limited resolving power of the analyzer. The vibrational component is produced by the excitation of low energy vibrational modes, both the initial and the final state, Finally, inhomogeneous broadening can originate from the presence of unresolved core level components in the spectrum. And again, we'll be looking at X-ray photoemission Ois spectra in our next video. Thanks for watching.